Okay, I'm back. Let's start. The point of this lesson is to talk about why is it better to write tests before writing code? How can you even do that? What kind of a mindset do you need to have? And we'll talk about two different mindsets that are involved in writing tests: inside out thinking and outside in thinking. We'll talk about how do you lay requirements in a test, how do you make your tests to act as living documentation of your code, how do you thoroughly test everything, how do you apply TDD for developing enterprise software, how do you apply it for problem solving, how do you apply it in job interview, and what is red green refactoring, and what are the benefits of writing test first as opposed to writing test last. Let's talk about the two design choices that you have for a system. The biggest problem in test first approach is that you're essentially testing something that doesn't yet exist. And what does that even mean? How can you test what doesn't exist? And this feels like an egg and a chicken problem where you are doing something for something that doesn't exist. What's the point of it? And the point of it is that it will happen essentially at some time, and it can happen in two different ways. First way, you start from the highest level components, and lower level components, if they're needed, will be uh, mocked out, stubbed out, dummies. And when you apply outside in thinking, you start from a chicken basically. And your point of view is customer. You understand what needs to be done, but you don't really understand how it needs to be done. However, you do need to understand it because you are going to be consuming components that are needed for your system. They will happen eventually. And this just means that you either fake them immediately or you will have to modify your high level system for every new component that appears. Therefore, you either make many changes for code you already have when you move one level down, or you need to have a really good understanding of what will need to be done. Inside out kind of thinking is the opposite. You see full picture, but you start from the lowest um, level component. You understand that this component must happen, and you start from something that must happen. That is the core. And from the core, you move outwards to high level components. And this means that when you are at the core, you are not depending on anything. And when you expand with what you already implemented, you simply add behavior on top that points to the core, therefore, that is also still implemented. Inside out is a better approach because it's easier to test it. And it's easier to think that way because you simply write, implement components that don't have dependencies from what does not exist. It's one thing to write tests for code that doesn't exist, but it's a whole different thing for writing code which has to communicate with code that doesn't exist, because you'll have to fake it. So that is extra effort for you. Therefore, inside out is more effective, easier, and faster to develop. Outside in is not so much recommended because you will need to mock everything out, stop everything out, you will need fakes, and we will be forced to think about dependencies even when we potentially might not need to think about them. For example, if we're working with a controller, what does the controller get data from? We'll need to think about that. And when we move one level down, let's say a service, where does the service get data from? We'll need to think about that. And it's, I think, nearly impossible for a beginner to do outside-in development because you need to understand all those details. And as a beginner, you will likely lack that kind of understanding. And therefore, inside out, just starting from a model, then moving to some domain component, then moving to data service, then business service, then API, then web API. When you move it upwards like that from the core, it just comes gradually, the design, and it's fine. Gradually, you realize what you need and what is the definition of done for that specific thing. Outside in can be mixed with inside out. It's nice to be able to understand what we need in a big picture. That is outside in. And sometimes it's also nice to just have that biggest component done immediately, discarding all the design and just having dummy return values so that other components could communicate with it. For example, if it's a controller, highest point of view, you just hardcode the return values so that other components can consume that component. That's quite fine for outside-in design, because later you can replace that dummy data with actual implementation. But that actual implementation can be done way after, starting from a model, starting from the most deep things at the core and moving outwards. This was probably a bit hard to understand, but now let's move on to very practical aspects of how you apply TDD. Imagine a very complex scenario. It's neither inside out or outside in. You're in the middle. You neither have the lowest tier parts, nor do you have upper tier parts, but you need to implement the service. Before you do anything, again, you need to understand what is a requirement. What do you need to do in order to implement it? And if you start thinking about everything, about full system, you'll be lost immediately without even starting. All you need is to find the point that is your implementation and the points that interact with that point. When you find that, you will understand what relations are you developing, or sorry, what unit do you have, what relations it has with other components, and how will it be consumed. And a concrete example for this, let's say we are creating an appointment service. More like outside in approach, because we do not have the needed component. We don't have anything. We just have a requirement to make a service. Proof of concept. So you need to make it ASAP and it needs to be tested as a proof that it works. Basically, a service is something that provides logic in a broad sense. And your requirement is to create a service that creates an appointment if time is not taken. And to get all appointments belonging to a person. Those are your requirements. We will stick with the first one. How do you create an appointment given a daytime is free? We start from a test. And our most simple test is not testing those methods yet, but just how do we create the service? What do you need? Not every service, but most services involve some data access object, a repository per se. And appointments repository is something that appointment service will consume. Therefore, when we create appointments service, we need to pass appointments repository, which gives us data, appointments, in other words. And if we don't pass it, it's null argument exception that will be thrown. Our first test is just for a skeleton. It's testing the most simple scenario. How do we create a service? So we create a service by passing nothing and it fails. Note that at this point, we don't have a service itself, nor do we have the repository. So we continue and add a skeleton for appointments repository interface and a class for appointment service. If we run the tests, they will run, build, but will be read. And if we want to make tests pass, we just add the validation for the argument. We pass the repository for constructor, and if it's null, we throw an exception with name of the type that we passed, which is appointments repository. Now, we tested that creation fails if you pass null. And we're not testing success scenario because success scenario will be covered with this test as well, so it doesn't matter. However, we need to test under what conditions can we create an appointment. Logically thinking, appointment can be created only if the date range for the date we want is available. And when we're creating an appointment, we basically say, for this person, from this time to this time, I want to reserve time for myself, for that person. And my initial draft for this method was horrible. And you can see we have taken date, person ID. Person ID doesn't matter basically. It's just a link with an appointment, so it can be anything. But date is essential. Date is what matters, and therefore I specify some date. And initially I thought that, if I pass a taken date, maybe I can return ranges of dates from and to that are taken. But this felt awful. It didn't feel right. The design was crooked. And I managed to know that by writing tests. Anyways, right now we have bigger issues than just design. Our service doesn't implement create method, and it doesn't implement, and there is no appointment model. and there is no get method for repository. So we need to implement all those things. So we cleaned up the design a bit because we realized, well, we need a range of dates and not just one date. And when we get something by dates range, we actually get a collection of appointments and not a collection of more date ranges, because it's simply more easier to work that way. Now we see missing methods and we need to implement them. We start with appointment, the model, because it's the most simple. Um, it's nothing special, just almost like your normal DTO, though it's not DTO, it's just a model entity because it has ID. Well, it's not really entity as well. Eventually it should be, but not now. Anyways, we have appointment with person ID from to dates. We create appointments repository with create method for appointment and get method for all the appointments between that date time. And finally, we implement or at least create a skeleton for the method appointment service. Create. We pass person ID, date time from to absolutely everything that can be done without thinking at all, because all this was just generated by right-clicking, auto-implementing stuff that is required by the test. Absolutely trivial. Individually, each of those is trivial. We move on to improving the design and improving the test. Another improvement in design is that I realized that if our appointment looks like this, which contains person ID from and to, and our appointment service in creation method passes person ID from to, isn't that just an appointment? And therefore, my create method became to just accept an appointment itself, an appointment candidate to be precise. And it can be any appointment, it doesn't matter at all. The thing that determines if appointment can be created is not my service, but my repository, because it will return either no appointments for the given range, or it will return one or more appointments for the given range. And having more than one appointment for the given range means that, well, the time is occupied and I cannot make the appointment. It doesn't matter when the dates are occupied, the fact is the same. I cannot make an appointment if there are already appointments for that date time. And you will see this in the method. I tried to get appointments using the datetime range, and I only create the appointment if uh, the datetime range exists, if no appointments exist. And actually, I don't handle that case yet because I simply didn't write a test for it yet. And this was the implementation for this particular test, which simply says if there are no appointments for a given time, I verify that I created an appointment with the candidate appointment. And as you can see here, there is no way it can fail. It just calls repository method. Now, in another case, when appointment actually exists, and you can see that appointment exists in here, because here I say that repository for appointments will return any appointment. One appointment, an array of appointments with a single appointment. This means time was occupied. I didn't create 2 or 3 appointments because I still wanted to be minimalistic. Either way, we create a service with the mocked repository and we do the creation of the candidate. We store it to a local method and we assert that that method for creation throws an exception. Appointment unavailable exception. Exception didn't exist at the time. I implemented the exception, which looks like this. Basically, it says which person cannot book an appointment, and it says which time it tried to reserve and which time was occupied. And what do we need to do? Remember the appointments any section? The if statement, we just throw an exception instead of ignoring it. And for final touches, we add null validation, that if we pass null for appointment when creating an appointment, well, we don't allow that. And we expect that it throws null argument exception. Here we added a validation segment for null. And the end result, we naturally, organically created appointment service that is decoupled, that has 4 parts, basically appointment service itself, appointment model, appointment unavailable exception, and appointments repository. That is our appointment service. And if you look at the tests, you can clearly see what are the conditions for appointment service and how it works. We can read as follows. Create when appointment null, throws argument null exception. Create when appointments exist at the time, throws appointment unavailable exception. Create when no appointments exist at the time, creates appointment. New when null arg, throws argument null exception. Like this, we understand under what conditions we can both do the creation and initialization. What are the results? Basically, you witnessed that we improved the design 2 times while writing tests before writing implementation. We documented how the service behaves, because you can clearly see that through test cases. We had 100% code coverage. It was fun. It was fun doing this. It was fun because instead of debugging and writing code that doesn't work and just trying to figure out in pain how it should work and just running, failing, and so on, we just tested it, and we didn't have to use debugger because our bugs, our failures were localized by the tests. And this basically proves that no matter what code base you're at, for any kind of new code, you can test it. Anything can be tested. Of course, we don't test old code because we don't know fully how it works. It's risky. But for new code, there is no reason not to test it. Now let's move on to a slightly different aspect, problem solving for test-driven development. every problem solving solution, if it's any complex, will give you constraints. And it doesn't even matter if it's complex, it has constraints. Every problem has constraints. And when you think about constraints, you might think that it limits you, but actually constraints free you. Because if you play by the rules of the game made by the constraints, your problem can be so much more simple because you don't need to think about everything. You just need to think about the game you're playing. Constraints help us by eliminating the things that we need to care about. It cannot be null. Don't validate for null. They didn't ask you. It cannot be more than 10. Well, then you're working with single digits. That's your rules. Use them to your advantage. If life gives you lemons, make lemonade. Complex problems, complex algorithms could be replaced with words like big or composite. If you have a big problem, a complex problem, split it into smaller problems. And if those problems are still complex, split it again until every split problem by itself is trivial. And if you do need to test each of those, or like if you want to test the big problem, testing the big problem as a whole might be as difficult as solving the problem as a whole before solving steps. And therefore, for big problems, you might need to split each step or group the steps into components and then write tests for those components separately for the whole problem. Because otherwise, you might have it not working and you will only be able to realize why is it not working through debugging. And in TDD, well, why should we debug if we can just write a test and localize the bugs? When you broke down the problems, you need to make a plan. And basically, the plan is what is needed in order to implement each individual step. And then how do you combine small individual solutions into the full solution to the problem? And here I took an example which is not trivial. It took a few hours for me to solve. The last time I did it last week. It's a medium difficulty problem taken from LeetCode, and you can find the problem itself in the link below. Basically, it says like this: there is a single number, and you need to apply steps 2 times. So for a given number, you need to pick a digit, and a digit is something between 0 and 9, and another digit, again, something between 0 and 9, and both digits can be equal. Basically, your task is to replace x by y in that number. So replace one digit by another in that number and do it 2 times. So you get 2 numbers. And numbers cannot have leading zeros. For example, it cannot be 0, 0, 1. It can only be 1, 0, 0. And you need to basically find the maximum difference between 2 numbers. And as a whole, this problem is insane you might think about, what the hell am I supposed to do? Where do I even start? And the answer is, where do you start? You start from analyzing the examples you have, or writing your own examples if there aren't any. Luckily, websites like LeetCode gives us examples with problem-solving assignments. And let's look at it. Input is 555, and it says output is 888. It's impossible to understand how do you get the output immediately, and therefore there is an explanation. And it says you take 5 and replace it with 9, and that's your first integer. And then you take 5 and replace it with 1, and that's your second integer. And then you subtract 999 from 111, well, the other way around, and you get 888. And they give you another example that if you have a single digit, then you replace that with 9, and the other one becomes 1, and 9 minus 1 is 8. What conclusion can we make from this? Basically, the conclusion we made is that A needs to be the biggest, B needs to be the smallest, so that A minus B produces maximum. Maximum by itself might sound that we need to find all the possibilities, but we are playing by the rules that are given to us by the constraints. And another thing is that digits, we work with digits, so something between 0 and 9, and we need an appropriate data structure for storing that, for working with it. Now that we have a plan, we add steps. What will we need? Now that we have constraints, we break down the constraints into the steps that we will need to do. We will need to split an integer into digits, and that is basically we will need to convert integer into array and array into integer. Next, we will need to find the biggest A, and we'll need to find the smallest B. The biggest A is a number that starts with 9. As soon as we can replace a digit closest to the left with a 9, we do it, and that's how we get the biggest. The smallest, however, is a bit more complex, because we can only replace it. Basically, the smallest digit is 0, so we want to replace it with 0. However, if we are at the first digit, we cannot replace it with 0, because it would break the rules that we play by. No leading zeros. So if the first digit is 1, we cannot replace it with 0. However, if the first digit is 2, we can replace it with 1. So basically, the conclusion, if first digit isn't 1, we make it 1. And if second or other digit isn't 0, we make it 0. So the first digit that we can replace, we replace. That is the essence of this problem. That is how it's broken down into steps that we need to implement. And how does the full solution look like? We make a plan. Max difference solution solve method looks like this. We convert the number into digits, and we find the biggest number out of those digits, or rather a number that needs to be replaced. Because first we want to understand what we want to replace with what in order to find the biggest number, and what we want to replace with what in order to find the smallest number. And then we need to perform the replacement for one digit with another in the digits array, and we return a result, which is a difference between the biggest and smallest, A and B. Comments are your friends. Use them for making a plan. And first test case, just literally write down everything, all the example inputs that you had in the example, and run the test. There is no validation, so there is no need of writing a separate test case because the behavior effectively is the same. And if you're doing fine, it's going to be quite easy. You just go back to solution, hack it, make it work, run the test, make sure they're green, refactor, run the tests again, and you're done. However, for complex problems, it won't be that easy. Because complex problems will have complex tests if you don't break the tests down as well. And if you have complex tests, if test fails, it will fail for multiple reasons and they won't be localized. And tests themselves need to be broken down as well. And so if you're not doing fine, if you're still finding bugs, even if you test it, it's really hard to thoroughly test that. You need to split it into parts, extract related components into extract related functions into components, and then test those components separately from the solution. And look how it all came together to me. Basically, I noticed that we have a converter for digits, and we need to convert from and to int, given a number, or an array of bytes. Bytes because that's the smallest data structure for storing a digit. So we pass a number, we get digits. We pass digits, we get AX and AY, which is what we place with what. And we then perform the replacing itself. And so we have three components, essentially: digit converter, replacements finder, and digits replacer. That's all. And with this, we have our solution. And with this, we can test individual components easily. Test becomes trivial, and for this one, for example, if we pass a number 1 to 3, we expect that it will be split into numbers into an array 1, 2, 3. We check that, we get that, we say we're happy. We check the opposite, that if we have an array with 1, 2, 3, we expect that we'll get the number back with 1, 2, 3. That's it. That's our trivial test method. When I started solving this problem, first, I actually didn't have separate components. I did have separate functions, but they were all private and they were all untested. Only the public facing function was tested, because to me, you don't have to test private functions. And if you have to test private functions, if they do get in your way, then please split them. Split them so they can be tested. As I mentioned in Saturday's lesson, adding attributes like internals visible to or using reflection for testing private methods is not an option. It just implies some poor design. And when I split them, it made a lot of sense. It became, I wouldn't say more decoupled, but it was better organized because different responsibilities were at least in different classes. My solution was still coupled with all those responsibilities, but it didn't hold any of it by itself. There is, of course, no need for an interface in this case because my solution will not change. I'm happy with it, and there is no need to be obsessive with swapping everything under an abstraction. And now the part we all waited for, it's TDD in job interview. When you go to job interview, especially the final parts, you will be asked to write code, and sometimes it's on a whiteboard, sometimes it is with an actual PC, with an actual IDE. And if that's the case, utilize what you have to full potential. Create tests and show that you can do TDD. Interview, as the name implies, is more that they question you, but it's fine to keep a dialogue as well. When they ask you to solve some problem, start from the most simple case that is included in the requirements. If you're not asked, let's say, to validate for null, or for empty string, or for default int, then don't do it. Just implement the most simple case that is asked for you to implement. And if you don't understand the problem, it's perfect because TDD gives you time. And TDD, basically, as you write the test, you communicate with the interviewer, and you can ask about the expectations. Like, you can just talk with them. You can ask them, given this, what would be the expectation? And they will tell you. Your job is to write code for the problem. And your job is to break down the problem. And extracting the requirements or telling the requirements is job of the interviewer. So don't be afraid to ask them to get those requirements. And if you want, you can also write multiple tests for multiple requirements, if there are any, but it's optional. But you should implement a single test at a time. Like, basically just leave empty tests that you will eventually implement. And implement the most simple test, run the test, clean up, continue. Like this, worst case scenario, you will only do the most simple case. It's impossible not to do it because it's trivial. If you broke it down properly, it's trivial, it's easy. And clean up. In job interviews, it's much more valuable to show that you can write good, clean, bug-free code rather than do a lot of dirty work. There's so many people who can do a lot of dirty work or type fast, but you're not paid for that. You're paid for delivering quality solutions and demonstrate that you can do that through TDD. And given that you implement a single case fully clean, move on to the next case. Implement it fully clean, move on to the next case. Step by step until you go and implement full what is asked. What are the benefits, you might ask? Well, employer will be pleased. I don't think that many people will do this unless they are asked explicitly, but it's obvious that you'll have multiple benefits for it. You will show that you understand best practices like TDD. You will show that you know how to multitask, and I mean that you understand how to both write code as you talk with the interviewer and how to extract requirements from the person you're talking to, how to break down problems, how to do them step by step, how to keep it small and work in increments, and how to not be redundant, like how to not make things that are not required from you. For example, if you're not required to print the result in the console, if you do that, it's a minus for you. That's not what they asked. That's just a workaround for what they asked. What they asked is to demo that your solution works. and the best demo is tests. So perform TDD and employer will be pleased. Now, why would you write test first as opposed to test last? Obviously, if you write test first, by default, your code is tested. You cannot forget to write code if you write test first, but you can't forget to write tests or making an excuse that you're on time pressure. Writing test first enforces you to test your code. So it results always in higher code coverage and probably testability. And as I mentioned so many times, when you write a test, you have more time to spend understanding the actual problem. Why should I waste my time on a problem that I don't fully understand? Writing a test is trivial, so as I write test, I might come to a realization that the problem I'm solving or testing is not really a problem that I need to solve or test. As you can see here, if I need to go from point A to point B across the labyrinth, maybe I don't need to step into the labyrinth. Maybe I can just walk through its contour to the next side. So think outside the box and keep it simple. Keep it simple and convenient for the consumer. When you design a test, you design inputs and outputs. You design minimalistic relations that will involve the unit that you're making, the unit that you're testing. So keep it simple. And as I said, problem might appear to be more simple than you thought. And so a design that initially might have appeared complex might end up being simple if you give some time and think about it before just coding a solution. Coding a test is easy, and you can definitely think about the solution as you go. And what is the flaw of TDD? TDD is essentially red-green refactoring. So you first write test, you then implement a target for that test, you then run the test, see if it works. If it doesn't work, you fix it. If it doesn't work because it has an edge case, you write that edge case or a whole new case. You run the test, you fix it, and if it's fixed, you refactor the test, you refactor the code that it tested, you run the tests. If it's green, raise the PR and deliver. But in between, you can do horrible hacks and just push code fast, because your goal in TDD is to be fast, is to write testable code fast. And only when you're done, when it's working, refactor. And I'm done. When I mean by done testing the first case. Only then refactor the code that you tested. And more thoughts on TDD. No matter where you work, practicing TDD is up to an individual. If your team doesn't do TDD, it doesn't mean that you're not supposed to do TDD either. It's up to you. As long as they're practicing unit testing, you can still practice TDD by yourself. The end result will remain the same. It's definitely not easy to get started with TDD because it requires for you to inverse your brain. But once you have done it, it's awesome to reap the benefits. And summary, in order to ensure that everything is tested, write test first. You're not supposed to know all the implementation details. And that's why test helps, because we have time to think about it. All we need to know is what is the definition of done? What do we need? And tests help us define those requirements. Be minimalistic and don't implement more than you're asked. Testing is easy and fun, and in tests you can make little programming experiments, because usually tests are isolated from everything else, and usually they're not really related with one another. So in different test suites you can apply different experiments as long as they work, and if they don't, well, you just refactor. So have fun writing tests, because TDD is awesome. That is all I had for today. Now, two comments. I wouldn't actually say test first leads to higher coverage. My colleagues frequently write one test that asserts the result isn't null, then implement the full code and claim to be doing TDD. Well, that is not test first approach. That is they didn't test their code. Test first means that you first write the most simple case, which is null validation. But like you saw in my examples, I didn't end with that. I then continued with another test case, because that is not the requirement. The requirement is not that given null, it throws exception. The requirement is, on top of that, that given an actual model object, it returns the expected results or invokes the expected behavior. So what you're saying, TDD, that they claim TDD, is definitely not TDD. It's just lazy approach to testing and lack of professionalism. And besides, it doesn't cover code. It's not tested. It wouldn't pass PR review if I was reviewing the code. And to set the real benefit of writing the test first is you see it go red and know that it's production code that made it go green. That's true. If you write the test last, you only ever see it green. That's not true. Not necessarily. What if your test doesn't actually run, just always green? Wouldn't know about test first. That's one benefit, yes. But I consider this benefit the least benefit, because writing test is trivial. And if test fails, you will know it regardless of writing it first or last. I was countering writing the test first leads to higher coverage. It still leads to higher coverage. What your colleague did is not writing test first. He didn't write test. That's the problem. Your colleague didn't write test. If he wrote test, if he fully tested, it wouldn't be just a test for null. You can write test to pass, and you can also write test to fail. And that's exactly what you should do. And your colleague just wrote test to fail. And I really hate this approach of classical TDD, which immediately makes test fail, which is just makes an empty method and runs the test explicitly. If you are proficient with it, it's a waste of time doing it, because I haven't had a single problem in 3 years of practicing unit testing that my tests were failing for reasons I didn't understand, or at least for reasons that I wrote test code with logic after writing a test, code with full logic or with partial logic. I hate the mandatory requirement of writing it as stupid as possible, like return 0 or do nothing. I hate that. It's not supposed to be that way, because the fact that test will run or not really is 99.99999% guaranteed, at least from my experience. If you are proficient with it, it's a waste of time doing that. I do agree that you should start simple. Yep, we clearly disagree. If you are proficient, you basically implement the most simple case, but implement it and not just make the method empty or zero, return zero. To me, it's not very beneficial. I do understand the benefit, but maybe if you're just starting out, but if you're proficient, no, I'm not a fan of it. I don't know if there are any students, but if you have any questions, please ask. You and to test what happens when the requirements are met, but you also want to test for when the input is incorrect. We know the code will work. We are designing it to, but testing the code work prevents breakage in future builds. Testing edge cases ensures that the code will recover when expected data is entered. Yeah, it doesn't necessarily ensure that is um, recovered from errors, but it ensures that we are aware of errors. Tests are documentation, so by defining tests for edge cases and for cases when it fails, we can just read them and know under what conditions they're failing. And it's very important to have that. And for every bug that we deliver, write a test because it's a proof that that bug is fixed and handled and no longer causes a problem. That bug tests for bugs I think are what um, error recovery is. What is a test for error recovery? It's a test for bug. That is true. However, if it's an edge case, um, if it's an edge case that does happen, yeah, you will probably discover it eventually. And I mean, you will either have untested code block that will appear inside um, code coverage, or you will have a bug that will happen eventually, and that bug will require you to either well, to modify code basically and write a test for it so that it's work. Prove that the bug is fixed. Yes, for getting, yeah, that's why we do not rely on tests. Even testability might show 100% the code coverage. We cannot rely on that because we're human and we forget things. We make mistakes. Testers test code on top of developers, and then QA on top of testers, and then in the end, customer will find the bugs anyways. It's multiple layers, and we want to make sure that we minimize the amount of bugs reach the customer. Yes, in fact, they're roughly 30 times cheaper statistically when you catch them in writing test stage as opposed to catching them in production. Yes, that is obvious. Edge cases are obvious. And as I showed in my examples, for testing edge cases, what if you pass null appointment? What if you initialize a service with null repository? Again, it throws an exception. I think this test for testing validation appointment service is with those edge cases. It tests all the scenarios that can be there. Yes, that's TDD. I don't claim that TDD prevents production errors. Nobody does, I think. It's just another layer of protection against bugs. That's why developers are not enough for testing code. That's why testers are not enough for testing high risk code. And that's why we need QA on top of all that. And that's why it's not even enough, anyways, because it just happens. However, with more layers of testing, we reduce the risk more and more. And that's why it's important. And that's why it's important to minimize the bugs that leave our code from very early on, as early as actually even before writing code at the planning level, planning stage, architecture. If the best kind of code that you can test is actually no code at all. If we plan properly, that we don't even need to write code in the first place, then that's the best. And that's the way to minimize code. That's why requirements gathering is so important. And design. Yeah, that is such a good point. That requirements are lacking, bugs happen. Which is, in fact, at least from my experience, requirements are lacking most of the time. Especially architecture. Yep. Yep. All right. If there are no more questions or remarks, I think we'll call it a day. I'll try to come up with homework later this week. Probably will be problem solving and testing uh, an easy lead code problem that has at least a few steps to solve. In any case, thank you for your attention, for your time watching me, and see you on Wednesday when we talk about how do you minimize testing code, what tools do we have at hand for .NET. We'll talk about auto fixture, and we'll talk about fluent assertions finally. See you on Wednesday. Bye bye.